the next, I would like to invite over here from the Dr. M.Shotts, and she is currently a senior scientist, global analytical and food safety, product stewardship for Abbott Laboratories nutrition business. Her primary responsibility is working closely with the suppliers and plans to run the contaminant program to ensure ingredient and product safety. She works with private organizations, government agencies, universities, and laboratories to ensure product quality and safety through use of globally harmonized, fit for purpose test methods and standards. In addition, she works on method development, emerging issues, food safety, and sits on a committee for protecting our products. Mei-Ling earned a Ph.D. degree in biochemistry with a minor in business from Florida State University and a Ph.D. in food science and technology at the Ohio State University, Columbus, OH. I would now like to invite on screen Dr. Mei-Ling Shotts, and she'll speak up over here about adulteration and the impact it has on our industry.
Hello, my name is Dr. Mei-Shotts. I work for Abbott Nutrition, and today I'll be talking about adulteration and the impact it has on industry. I'm going to give you a definition of economically motivated adulteration, which I'll call EMA, which is the intentional sale of substandard food or food products for the purpose of economic gain. There's different types of definitions of EMA that you'll hear about, with the intentional substitution of an authentic ingredient, the cheaper product, dilution, flavor, color enhancement, substitution for one species for another. But the basic aim of EMA is to inflate by fraudulent means. There are roughly 7 types of food fraud that you'll most likely hear about from the FDA and different regulatory agencies, which would be substitution, concealment, mislabeling, theft and/or diversion, unapproved enhancements, counterfeiting, and dilution. Mind you, there's still more than 7, but these 7 are the most typical that you'll see. I kind of want to talk about intentional economic adulteration and the impact it's had on industry in the last 50 years, and to kind of shape where it comes from to today. In 1977, this case was pivotal with Beech-Nut. It's where the FDA revealed that this apple juice company that was supposed to be selling 100% pure apple juice actually was selling a mixture of beet, sugar, apple flavor, caramel coloring, and corn syrup. This was the first time ever in the history of any adulteration case where the CEO/president of Beech-Nut and/or any company was sentenced to jail and was also personally fined $100,000. The company itself was fined $2 million and had a class action suit of $7.5 million. In 1981, street vendors in Spain sold colza oil, which is a lubricant for machinery, to the customers as olive oil. Olive oil in Spain isn't typically consumed raw. They don't always cook it fully. They put it on salads, and this caused a larger issue of people getting sick due to toxic oil syndrome. Not just the fact that it was colza oil, but the fact that they used it without cooking out any other types of adulteration or seeing that it wasn't truly olive oil. This caused a lot of musculoskeletal issues that killed over 6,000 people in Spain. The World Health Organization has a lot of data on that if you're interested in this topic. In 2008, most of us remember the milk and infant formula adulteration scandal with melamine. It caused over $18 billion in fines, recalls, and reparations. Over 300,000 people became ill. More than 50,000 infants were hospitalized. And at that time, since infants had passed away. And to this day, out of those 50,000 infants, they still have medical issues that they're still addressing. In 2013, Honey Solutions and Grub Farm were fined $2 million in fines, and 5 of their individuals were charged for illegal importing and selling of adulterated honey. And this has actually caused a ban in the US saying that honey cannot be imported from China anymore. In 2015, cumin was adulterated with undeclared peanut products. This was a huge issue, and over 700 different products recalled by 40 different manufacturers. So the peanut products were in tomato paste, frozen pizzas, and a lot of products used for spice and mixes that people didn't really think about, and that's how it really affected the industry in 2015. So these are some more recent ones. This was actually from November 9th, and talking about honey producers that are struggling with adulterated imports because it's the worst harvest they've seen in decades. In addition, this article was from November 16th, talking about the GMO tech causes clashes among the Indian food sector. And if you read the article a little further, it also talks about adulteration and import issues. And one article that was from November 17th talks about the adulteration of paneer and the cream destroyed during transit. So that kind of wants me to lead into what the common adulterants were for 2019. In 2019, we had organic and non-GMO food and food products. I'm highlighting this because I'll be talking about it a little later in the types of mitigation strategies that we could use to protect against food adulteration. In addition, milk, oils, fish and seafood, honey, fruit juice, coffee and tea, spices, wine, and wheat. So the first one, which was organic versus non-GMO, we're going to discuss butter. So the organic food industry in the US has kind of skyrocketed. In 2012, it was a $28 billion industry. In 2016, it was a $47 billion industry. Butter is the third most consumed organic product in the US at 1.4 billion pounds a year. Butter prices in 2016 were $2,650 a ton versus in 2017 was roughly $6,000 a ton. The biggest differences in the organic versus conventional butter is the feed. So for organic butter, you have a non-GMO feed, grass silage and grains, versus a conventional butter, you could use any type of GMO feed, corn, and grain. One of my projects before was looking at the differences using vibrational spectroscopy with organic and conventional butter. I used 3 different types of near-infrared spectroscopy to see the differences between the spectra and if we could classify them and separate them well by just using the spectra. Thankfully, we were able to see that there was really good separation between their interclass distances after collecting the spectra and using SIMCA. You can see that the organic and conventional butters fell into their separate classes and were easily identified. And a lot of this was also paired with fatty acid analysis to see the differences in the bands of actually trans fat between the organic and conventional butters, which really helped delineate the difference between classes. This is one step to show that you can use this type of mitigation strategy to protect against food fraud. Another topic that made it on the FDA's top 10 list and is a huge product that is commonly adulterated around the world is milk. So we can see milk being adulterated with water, detergent, starch, urea, melamine, formalin, vegetable oils, other synthetic milks, hydrogen peroxide, ammonium sulfite, chalk, salt, etc. The list just goes on. There was a project that I used looking at a non-targeted method with mid-IR and able to see the different types of milk protein concentrates, not milk specifically. This was using a mid-IR analysis, and we were able to determine the classification of the milk or mixture in less than a minute. The performance was accurate and reliable, and it was robust, and you can see how it falls into different classes. And if it wasn't a pure sample of the whey protein or the non-fat dry milk, then it kind of fell into these mixtures, which would be considered adulterants. Another project that I've worked on is actually honey. The US consumes about 40 million pounds of honey a year. Only 48 can be supplied by US, and the rest has to be imported from 41 other countries. In 2001, the Fair Trade Commission banned the import of Chinese honeys since they were flooding the marketplace with cheap honey. And then again, we had talked about the 2013 Greb Farms was charged by the Department of Justice and had to pay a $2 million fine. In 2017, the American Beekeeping Federation approximated 28% of the honeys imported are adulterated. And this was a recent article posted in the EU about adulteration, with sugar syrups and being most widely seen in honey adulteration. So common adulterants for honey on the list below, and to the left is kind of a way you can tell if honey is adulterated really quickly. If you really want a really scary science project with your kids at home, you can hold a lighted match to the honey to see if it melts or if it starts to hiss. There's other things you can do at home if you're curious, just to kind of what they would call a poor man's version to see how it's adulterated. The FDA claims honey is a food that can only contain honey, and it must be named honey. And it can include the source of honey, such as clover honey, on the label. The issue is because honey is a single ingredient food, you don't need to include an ingredient statement on the label. So if the honey is a mixture, it must be labeled blend of honey or corn syrup or raspberry flavored honey. So here are 3 different types of honey ingredients packets on the back, where you see just organic honey, pure honey, and high fructose corn syrup, or the high fructose corn syrup, and all these other ones, and that was actually a honey blend. So I did another project with looking at honey. On the left, you see the AOAC method run on sugars for honey, and on the right, you actually see a Raman spectra that matches the same bands of the honey. The top 2 are pure honeys. The green one, the third one, is actually a honey sauce, and you can see the difference in the sugar profile with the AOAC method with LC that matches to the ramen, where you have oligosaccharides that you're not seeing in the first 2, that you're seeing right here in the Raman spectra that you don't get the clear delineation of. And then with the third one, you may have a sample that was labeled as pure, but there were oligosaccharides that were in it, and it was actually adulterated honey that we saw in this particular case. I also ran Simca analysis on this as well. We had pure honeys show up and adulterated honeys. These were potential adulterants that I had classified, but I didn't see any in the honeys that I had ran. And there was also honey mixtures. Most of them fell into the adulterated honey list. So a honey mixture would have been the corn syrup plus honey or anything like this. The adulterated honey was 100% adulterated, so 0 honey was actually in the honey itself. The nice thing about this analysis that we could use to mitigate food fraud is the fact that it's ramen and it's less than 3 minutes to get the spectra in order to see if it falls within one of these 4 buckets. In 2019, the food fraud, this was actually published by Food Protection to show different food frauds by the countries of origin. Now, mind you, these are the only ones that were caught, so the successful fraudster was not detected. So these are ones that were caught and reported, and these are the countries of origin in which the adulteration had occurred. So the label said it came from France or Denmark or Canada, etc. EMA is a global problem, and roughly 600 million people, 1 in 10 in the world, will actually fall ill after eating a contaminated food, and roughly 42,000 people die a year from that. Children under 5 years of age carry 40% of the foodborne disease burden, with close to 125,000 deaths per year. A number of countries where the source of ingredients were listed is how this was identified. And a recent EU Commission analysis showed a 20% increase in reports of food fraud in Europe in 2019. So now we come to 2020 with COVID. So COVID adulteration has increased dramatically. We've seen alcohol in Mexico being adulterated, spices and meat in the EU, dairy and spices in India, infant formula and vitamins in China, strawberries in Australia, fruit out of Pakistan, plant-based protein things worldwide. that have had associated with it. We also found some things that were most commonly adulterated in this past year due to COVID, which was turmeric, green chilies, seeds, ice cream, and coffee powder. So some of the things that I just kind of want to show you is that upon visual inspection of a product, some people can't tell the difference. That actually A is what you would consider a sugar, and B is kind of soap shavings mixed in with a rock sugar, and they were claiming it was rock sugar, but it was mostly soap shavings. So one of the things that we have discussed at length is looking at how you should visually inspect the ingredients coming into your facility to see if you notate a difference that could cause issues. This is rice that was adulterated with pieces of plastic. So once you boiled the rice, you can see the rice did not turn white. But if you look at the rice on the left, it looks like rice you would typically see before you boil it. And the rice on the right is pure authenticated rice. Another difference you'll see is a difference in labels. So the first bottle is actually the bottle that is the authentic bottle. You can see bottles 2, 3, and 4. There's a lot of differences, whether it is the picture on top, the way the font is lettered, where the P may be located, or the labeling of the year is different. It's down here on one and up here on another, or here and another. And the Grand Vin is in a different position as well. These were kind of just very dirty bottles to make it look aged and older versus this was a very clean bottle. And these are just things that you would see, and people weren't noticing the differences of adulterated alcohol in Russia until someone put all 4 bottles together. So if you haven't drank this bottle before, or you don't see it that often, the small details you wouldn't typically notice unless you were an avid drinker or perhaps in the wine industry. Another thing that we've been seeing due to COVID is a difference in the plastics or packaging, the size and shapes of the container that doesn't normally come in due to a limited supply or the supply chain having issues. So this one I want to show you has a plastic wrap around it of masking tape, where this one does not. And then this one is fake because they're not supposed to have this wrapped handle. And they claim that they had the wrapping on the handle because the plastic was not the same type of plastic they typically use because they couldn't get the same packaging due to COVID. So small things that add up can cause a chain reaction down the road due to adulteration and its impact on industry. And unfortunately, not every company has the manpower in order to look through all these instances or situations to ensure that their products are 100% safe. So in conclusion, I just kind of want to wrap up that EMA is an issue, and it is more prevalent and more concerning now that COVID has come back again with a vengeance, and there's more border closures and supply chain constraints are becoming an issue yet again. There's a lot of evidence to show that food safety and food fraud are interlinked. Fat and oils became a top category based on the number of requests of placing olive oil in as a modified product. Fish products are also followed around the world, and meat products other than poultry. There's a lot of non-compliance with mislabeling, and it's roughly 47% of what the violations are according to the EU. There's a lot of guidance from the World Health Organizations and food agriculture associations with the United Nations to help identify new suppliers due to the short supply and unavailability to businesses due to COVID and the supply chain constraints. So if you have questions, please feel free to reach out to them in addition to your local agency. And with the increasing number of customers who are now turning to e-commerce, there's a larger concern for them buying products that are supposed to be, for example, Coca-Cola products or craft products, and those are adulterated because people now have time at home to kind of rethink and rework the system. So there's a lot more risk coming around these times, and we need to have proper mitigation strategies to protect against food fraud. My expertise is more on the non-targeted techniques to help with raw ingredients and identification before it gets into the supply chain of companies. But as an industry as a whole, we need to work together in order to prevent food fraud moving forward, especially in light of COVID. And with that being said, that is my conclusion. I hope everyone is healthy, well, and safe. And if you have any questions, please feel free to reach out to me. And I look forward to meeting you all in person one day. Thank you.